Hello everybody and welcome back to Addvance Maths. Today we're looking at grade 7 plus exam focused questions on quadratic problems. Let's start with example 1, and it says the shaded rectangle needs to be painted. It has a length of 3x meters and a width of 2x meters. It's inside another white rectangle which borders it on 3 sides, with each border being 1 meter wide. The total area for the white and grey areas is 100 meters squared. That's going to be important information. Show that 6x squared plus 7x minus 98 is equal to 0, and hence calculate the shaded rectangle's area. Okay, so this shaded, the white and grey areas together is equal to 100 meters squared. So the total area of that is going to be base times height, which is going to be 3x plus 1 times 2x plus 1, which simplifies to 3x plus 2 times 2x plus 1, and that's equal to 100 meters squared. We'll use the crab's claw, a method to expand those brackets like this. Definitely use the crab's claw there so you don't make any mistakes. And then those middle terms will simplify to be 6x squared plus 7x plus 2. You take 100 off both sides and you get 0 equals 6x squared plus 7x minus 98 as required. Really nice question, that one. Now we've done that, we can use that to calculate the shaded rectangle's area. And so we're going to use this quadratic 0 equals 6x squared plus 7x minus 98, where a is 6, b is 7, and c is minus 98 to solve it. We can use a quadratic formula, or we could use a fancy calculator that does it for us, and we substitute a, b, and c into this expression, like that. If it is an add, it will give us x equals 3.5, and if it's a minus, it will give us minus 4.66 recurring. Try that yourself on your calculator to make sure you can type that in correctly. It's always something people struggle with. But if you did get those two answers, we now need to use that to find the shaded rectangle's area. And the key here is you have to choose which x to use. And a sensible x is to choose a positive x, because that will give you a positive length for the length of the rectangle. You cannot have a negative length of something because it doesn't make sense. So x is 3.5 will make sense here. And so we're substituting 3.5 into the width and the height. And that will give us a height of 7 and a width of 10.5. You multiply those together and the area is 7 times 10.5, which would be 73.5 centimeters squared. And that is the final answer. Okay, let's look at the next one now. It says there are n counters in a bag. 6 of the counters are green. The rest of the counters are red. James takes at random a counter from the bag without replacement. He takes another counter from the bag. The probability that both counters are green is 1/3. So let n squared minus n minus 90 is equal to 0, and hence determine the number of counters in the bag. For this, we're going to have to do a probability tree. For n counters in the bag, where 6 are green, so how many are red? Well, it's n minus 6. The number of counters minus 6 is the number of counters that are red. There's no other colour in the bag. So we start with a probability tree where you could take a green out first or you could take a red out first. The probability of taking a green, well, there's 6 green counters out of n total counters. The probability of taking a red is n minus 6, because that's the number of reds, out of a total of n counters. Okay, now you can take another green or another red. Probability of taking another green will be 6 minus 1, because you've got 1 less green in the bag, out of n minus 1, because you've got 1 less counter in the bag. Remember, he doesn't put the counter back in the bag, so there are still n minus 1. There are now n minus 1 counters in the bag. The number of red counters is still n minus 6, because we've not taken any red counters out so far. Whereas if you take a red counter out first, you've still got 6 green counters out of n minus 1, and you've got 1 less red counter, n minus 6 minus 1, over n minus 1 counters. Okay, those probabilities simplify to this. You should take a moment here and see how I've got those fractions. especially those second branches that rely on the first branch to tell you how many counters are remaining in the bag. That's quite tricky, but let's continue. It says the probability of both counters are green is 1/3. So the probability of green and green is 6 over n times 5 over n minus 1. And that's equal to 1/3. That's what it says in the question. The probability of two greens is 1/3. We can simplify that fraction to be 6 times 5 over n times n minus 1. And that's equal to 1/3, which is equal to 30 on the top. We can get rid of the divide by n times n minus 1 by multiplying by n times n minus 1. And then we get rid of the third. The opposite to thirding something is timesing by 3. That's like a third means divide by 3, so we times by 3. And so we get 3 times 30 is 90. We've simplified that, and now we're going to expand the brackets. We get 90 equals n squared minus n. We take 90 off both sides, and we're left with 0 equals n squared minus n minus 90, as required. And hence determine the number of counters in the bag. Okay, so we need to solve that quadratic, and we're going to factorize this one to solve it. You could also use the quadratic equation, but this one's a nice simple one to factorize. It becomes n minus 10 times n plus 9, which gives us that to make 0, either n is 10 or n is minus 9. Now, you can't have minus 9 counters in a bag because it doesn't make sense. You have to have a positive number of counters in the bag. So therefore, the number of counters in the bag is 10. So there are 10 counters in the bag, and 10 is the final answer. We've done. Finally, let's look at example 3. We're going to solve this equation. 2 to the power n squared over 2 to the power n times 4 is equal to 16. Okay, you're going to have to know your laws of indices here to solve this. And we'll start by noticing that 16 is 2 to the power 4, and 4 is 2 squared. This isn't a coincidence. The question has deliberately given us powers of 2 so we can solve it easier. So we're going to rewrite that as powers of 2. When you've got questions like this with powers, they quite often choose powers, similar powers. For example here, 2, 4 and 16 are all powers of 2. And we can always start by converting them into being written as powers of 2. That was our first step. We wrote 16 as 2 to the power 4 and 4 as 2 to the power 2. We'll simplify this now. On the bottom, we've got 2 to the power n times 2 squared. We can add the powers to be 2 to the power n plus 2. We'll multiply both sides by 2 to the power n plus 2, and that gets rid of the divide by 2 to the power n plus 2. We can now then add the powers on the right-hand side, because remember when you're multiplying two powers, it's like adding the powers. And we get 2 to the power n plus 6 on the right-hand side. And therefore, we've got 2 powers of 2. We've got 2 to the power n squared equals 2 to the power n plus 6. And those two powers must be the same to make the equation equal to each other. The powers must be equal. So therefore, n squared is equal to n plus 6. The powers must be the same. And we take n plus 6 off both sides. We get n squared minus n minus 6 is equal to 0. We'll factorize that as n minus 3 times n plus 2 is equal to 0. That gives us n equals 3 or n equals minus 2. Now, either of those make sense in the context of the question. We don't have to choose a positive one here because there's no reason why it has to be positive. In other questions, the context may mean that you have to choose a positive answer, but for this one, it can be either n equals 3 or n equals minus 2. Both are fine. And we've solved that problem there. Now I've got some problems for you to try. Okay, so I'd like you to pause the video and try these questions yourself. This will take you quite a while, so maybe 10 to 15 minutes. But when you've done these, you can press play and I'll reveal the answers in 3, 2, 1. Did you get it correct? Let me know how well you did in the comments below. Thanks for watching. this video from Advanced Maths, remember to like and subscribe to support the channel. We're covering GCSE, A-level and IB maths videos, and there's more resources available at advancedmaths.com. Thanks for watching and good luck in your exams.